Introduction to Parallel Programming in .NET Core. Let's have a look at the first video of this section. In this video, we're going to have a look at the Introduction to Parallel Programming. Parallel programming is something that every professional developer should understand, but it's rarely discussed or thought in detail in a formal manner. Software users are no longer content with applications that lock up the user interface regularly or take large amount of time to process data unnecessarily. Modern development requires the use of parallelism. Today's systems are no longer getting faster with each generation. In many cases, newer computers are actually slower than previous generation systems. Modern hardware is shifting towards conservation of power, with processing scalability coming from having multiple computer cores, not faster and faster CPUs. Our CPU frequencies no longer double on a regular basis, but Moore's law is still holding strong. Now, however, instead of scaling transistors in order to make processors faster, hardware manufacturers are scaling the transistors in order to add more discrete hardware processing threads to the system. This changes the way of how we should think about software. In order to take advantage of modern systems, we need to redesign and rewrite our algorithms to work in parallel. As with any design domain, it helps tremendously to have a common language as well as a common set of patterns and tools. Every computer that we buy today most probably has a CPU with more than one core, allowing it to execute multiple instructions in parallel. Operating systems take advantage of this configuration by scheduling processes to different cores. However, concurrency can also help us improve performance of individual applications with asynchronous input-output operations and parallel processing. In the past, parallelization required low-level manipulation of threads and logs. Visual Studio and .NET Framework enhance support for parallel programming by providing a runtime, class library types, and diagnostic tools. For .NET developers, this is an exciting time for parallel programming, as starting from version 4 of .NET Framework, Microsoft brings a set of tools to simplify parallel development. You can write efficient, fine-grained, and scalable parallel code in a natural idiom without having to work directly with threads or the thread pool. Main components making part of modern parallel capabilities of .NET are TPL, or Task Parallel Library, which provides a set of public APIs and namespaces and have as a main purpose make developers more productive by simplifying the process of adding parallelism and concurrency to applications. And plink, or Parallel Link, which is a parallel implementation of LINQ to objects that significantly improves performance in many scenarios. In .NET Core, tasks are the main abstraction for concurrent programming, but there are other support classes that can make our job easier. In order to fully utilize .NET Parallel capabilities, we need to understand the proper terminology and see some real-life examples of usage. In the next video, we're going to see the difference between parallel and asynchronous code execution flows.